Problem 1, use L'Hopital's rule. So when can we use L'Hopital's rule? It's when we want to figure out the limit of a fraction. Right? If we sub this value in, right, on the top you will get 0 plus 0. The bottom you will get 0. Right? So in total you will get the numerator 0 over denominator also 0. In this case, right, or in another case, if you sub in, the numerator get infinity, positive or negative, the denominator get infinity, positive or negative, right, you can use L'Hopital's rule. Then what is L'Hopital's rule? So this over this, the limit is this thing's derivative. Okay. Over this thing's derivative. Okay, if this is true, then we can use the L'Hopital's rule. Okay, by L'Hopital's rule, this is true. This equation is true. Okay. Then top's derivative is 1 plus secant x squared. Right, bottom's derivative is cosine x. Now you sub in, right? Now you sub in. Sorry. Now you sub in. You get secant 0, right? Secant 0 is 1. Cosine 0 is also 1. And you get your answer. Okay, so this is the L'Hopital's rule. Part B. Okay, again, if you sub in, you can see the top is e to the power of 0, it's 1, minus 0, minus 0, right? The top is 0. The bottom is subbing 0, it's 0. So 0 over 0, you can use the L'Hopital's rule. Okay, it equals the top's derivative, right? The derivative of the top over the derivative of the bottom. So the top's derivative, it's e to the power of x minus 0, minus 1, minus x. Right? The bottom's derivative is 2x squared. So now when you sub in, right, you put 0 in, you get 1 minus 1 minus 0, right? You get 2 0 squared. So it's still 0 over 0. So what can you do now? You can use the L'Hopital's rule again. Right, so it's the top's derivative over the bottom's derivative. So now the top's derivative is e to the power of x, right, minus 0, minus 1. Bottom's derivative is 4. Okay, sorry. Here it should be 3x squared, right? 3x squared. So now it should be 6x. Okay, same thing. You sub in, you get 0, right? It's still 0 over 0. So what can you do? You can use the L'Hopital's rule again. Right, top's derivative is e to the power of x. Bottom's derivative is 6. Okay, finally, when you sub in, it is 1 over 6. Right. So you can see you can use L'Hopital's rule multiple times as long as the condition is satisfied. Okay. Part C. Limit. Okay, again, when you sub in, right, it will be infinity over infinity. Okay, here we have a minus, but t to the power of 5, it's of course much greater than t to the power of 3, right? So the top, when you sub in, okay, it will be infinity. So what can you do? You can differentiate, right? But do you have to do that, right? You know L'Hopital's rule, but L'Hopital is not your only rule. You can imagine that when you differentiate it, you have to differentiate almost like 5 times until this power is no longer, right, until this power is 0. So you know L'Hopital's rule, but you don't have to use it, right? Because remember, it's just both sides divided by highest power. Right, for this type of question, you just use both sides divided by its highest power. So it's pi minus this plus this, right, over 1 plus this plus this. Okay. So the result when x is approaching infinity, these are all 0, right? 0, 0, 0, 0, 0. So the result is just pi. Okay. You know L'Hopital's rule, but L'Hopital is not your only rule. Okay. We have learned a lot of different strategies to deal with it. Part D. Limit x squared e to the power of x when x is approaching negative infinity. Okay, when x is approaching negative infinity, okay, you can think about it. When x is approaching negative infinity, your x squared is approaching positive infinity, right? Your e to the power of x is approaching 0. So you can't say infinity times 0 is 0. Okay, that's a very typical mistake. So you don't know. Then what can you do? If you want to use the L'Hopital's rule, you need a fraction, right? But here you have a multiplication. So how can you change multiplication to a fraction? All right, you have 2 ways, right? It can be just x squared over e to the power of negative x, right? You can do this. Or you can do it's e to the power of x over x to the power of negative 2. Okay. So both way, right? This is approaching 0, right? This is approaching. Okay, this is approaching infinity, right? This is also approaching 0. So both way you can use a L'Hopital's rule. But just think about it. If you keep differentiating this, right? If you differentiate this, you will get this. And you differentiate this, you will get this. The power is going to be smaller and smaller, right? And e to the power of x, you differentiate it, you will always be e to the power of x. So we don't see an end to this differentiation. However, here, when you differentiate this twice, right, you get a constant, which is quite good for us, right? So which one should we choose? Right, this one should we choose to do, okay? So we make it equals x squared over e to the power of negative x. X is approaching negative infinity. When x is approaching negative infinity, top is approaching positive infinity. Bottom is also approaching positive infinity. The positive infinity over positive infinity, we can use a L'Hopital's rule, right? Equals the top's derivative over the bottom's derivative, right? Which is 2x negative e to the power of negative x. Right, now the top is approaching negative infinity, right? The bottom is approaching same, negative infinity. So we can use the L'Hopital's rule again. Okay, so it's 2 over e to the power of x. Okay, now when x is approaching negative infinity, e to the power of x is approaching 0 from the positive side, right? Then 2 over e to the power of x, it's approaching positive infinity. Okay, so the result is positive infinity. Sorry. Yeah, here's a mistake, right? When you do the derivative, it will be negative e to the power of negative x. So x is approaching negative infinity, then negative x is approaching positive infinity, right? So e to the power of x, it's approaching e to the power of negative x is approaching positive infinity. So 2 over e to the power of negative x is approaching 0 from the right side. So the result is 0. Okay. Okay. Part D. Part E. Okay, first when you sub in 1, you will get 0 here, right? 1 over 0 over like something 1 over 0. So it looks like both of them are not defined, so is the limit not exist? So what you can do is this. Right, you can do this first. And after you do this, it is a fraction. It is a fraction and it will be 0 over 0. Okay. When you sub x equals 1 in. So you can differentiate both sides. Okay, by L'Hopital's rule, you can differentiate both sides. It will be 1 minus 1 over x. Okay, the bottom, it's this part's derivative, 1 over x times x minus 1, plus ln x times this part's derivative. Right. So now when you sub in, it's still 0. Right, when you sub in, it's still 0 over, when you sub in, right, it's still 0 over 0. So you can use the L'Hopital's rule again. And the top is 1 over x squared. Right. The bottom is this part's derivative, negative 1 over x squared, x minus 1, right, plus this times this part's derivative, it's just 1, right? Plus ln x derivative 1 over x. Okay, now you can multiply x squared on both sides. It will be net 1 negative x minus 1, right? Here it's plus 2x. Okay, it's just limit 1 over x plus 1, right? When x is approaching 1. So it is 1 over 2. Okay. Part F, limit 3x plus e to the power of 2x over x squared plus e to the power of 3x. Again, because it's infinity over infinity, right? It's infinity over infinity, so you can use the L'Hopital's rule. You differentiate top, it will be 3 plus 2e to the power of 2x. You differentiate bottom, it will be 2x plus 3 e to the power of 3x. Okay, then you have to do it again, right, by L'Hopital's rule, because now it's still infinity over infinity. So the top derivative is 4e 2x. Bottom derivative is 9e 3x 2 plus. Right, so again, it's infinity over infinity, so it's right 8 e2x, and bottom is 27 e3x. And after you get this, you cancel out e to the power of 2x on both sides. So it's 8 over 27 e to the power of x. Okay, now when x is approaching infinity, this is approaching positive infinity, right? So the result is 0. Okay. G x tangent inverse 1 over x. Okay, x is approaching infinity. So again, when x is approaching infinity, this is approaching infinity. 1 over x is approaching 0, right? Tangent inverse 0 is approaching 0. So you don't know. So what do? Again, you change it to a fraction, right? So I want to keep my tangent inverse on top because it's easy to differentiate in this way. Right? X is approaching positive infinity. And now it's infinity, it's 0 over 0. Right? In this case, it's 0 over 0. So by L'Hopital's rule, it is limit top's derivative. Right? Tangent inverse something. The derivative is 1 over 1 plus its square. Right, so the top is 1 over 1 plus this square times, right, negative 1 over x squared. The bottom's derivative is just negative 1 over x squared. So these two cancel out. It's just the limit of this. So this part is 0, right? Then the result is 1. Last question. X is approaching infinity. So now it's something approaching 0, right? Something approaching infinity to the power of something approaching 0. So again, you don't know the result. So how to change this to a multiplication? Right? How to change this to a multiplication? Remember, e to the power of ln a equals a, right? If a is positive, right? So now this part is positive, so we can use that. This part is positive, we can use it. So it's e to the power of ln this. Okay, when x is approaching positive infinity. So because this is a continuous function, right? So this is a continuous function, so limit e is e limit. So it's e to the power of limit. Okay, this part ln a to the power of b, right? It's b ln a. So it's 1 over x times ln e to the power of x plus x. Okay. Then you can differentiate both sides. Right. Then you can differentiate both sides. Because now for this part you can use the L'Hopital's rule. So you differentiate this, you get 1 over e to the power of x plus x times e to the power of x plus 1. Right. You differentiate this, you get 1. So you can rewrite this as e to the power of x plus 1 over e to the power of x plus x. Okay, now you can differentiate both sides. So it's e to the power of x over e to the power of x plus 1. Right, and you differentiate again. It's e to the power of x over e to the power of x. Right. So this part is 1. It's e to the power of 1. The result is e.